You know that feeling when you have a fantastic piece of tech, something you really rely on, but the manufacturer just decides to stop supporting it on your system? Well, today we're diving into a story about exactly that. It's a tale of frustration, it's a high-tech detective case, and ultimately, it's a huge open source win. And this quote from the developer who did all this work, man, it just nails it. We're not just looking at lines of code here. We're really exploring this powerful statement against that whole throwaway culture, where perfectly good hardware gets left behind just because of software? All right, so let's set the scene. The hero of our story is this really high-quality piece of audio gear, the Presonus AudioBox. It's a pro tool, but for anyone on Linux, the company basically just abandoned it. This is a perfect example of what the developer calls vendor-locked suffering. And just look at this. The difference is night and day. On Windows or Mac, this thing is a powerhouse. You've got full control over the digital signal processing. But on Linux, without that official software, it becomes, well, a literal paperweight. The crazy part is, the hardware is exactly the same. Its entire usefulness is just crippled by a lack of software support. So what do you do when you're faced with a pricey, useless brick? Well, this developer didn't just give up. Nope. They put on their detective hat, and the process they followed is just a masterclass in reverse engineering. So here's the game plan. First, they popped the hood on the official Windows driver using a tool called Ghidra to see how it worked. Then they basically bugged the conversation using Wireshark to eavesdrop on the USB traffic between the device and the computer. With that intel, they could start building a brand new driver in Python to bring this thing back to life. And this became the golden rule for the entire project, a zero-assumption policy. See, in reverse engineering, if you make one wrong guess, you could waste weeks going down the wrong rabbit hole. So every single detail had to be proven with hard evidence from that captured data. No guesswork, period. And here is our first big plot twist. The obvious assumption, right, was that this device was using some secret, super complicated, proprietary language to lock people out. I mean, it's a common tactic. But as the investigation got deeper, turns out that assumption was completely and totally wrong. This is the moment. This is where all that careful, methodical detective work is about to pay off, and the entire case just gets blown wide open. The big aha moment didn't come from cracking some kind of crazy encryption. It came from just listening. By analyzing all that USB traffic from Wireshark, the developer realized the device wasn't whispering secrets. It was speaking a totally normal, well-known, standard language. And boom, here it is. This table basically shows you the whole solution. That secret language? It was just USB Audio Class 2.0, UAC2 for short. It's an open standard that's been around forever. The company hadn't built a new lock, they just hadn't given Linux users the key. All the controls for volume, mute, everything, they were just standard commands. The whole solution was hiding in plain sight the entire time. Okay, so once the language was cracked, the next step was to write the translator. And this is where the project goes from investigation to creation, and the result is this beautifully simple and, dare I say, elegant Python driver. I mean, just look at how clean this is. The first step in the actual code is just 2 lines, one to create the driver object, and another to find the audio box and get it ready. That's it. The device is now listening. So you need to set the volume on the left channel to -6 decibels. That's just one single, easy-to-read line of code. All that USB complexity is handled for you, giving you direct, precise control. It's awesome. And it's the same deal for everything else. You want to mute a channel? Just tell it to be true. This is the real power of turning all that complicated reverse engineering work into a simple, usable tool. And finally, when you're all done, one simple command cleanly lets go of the device, handing control back to the operating system. It's powerful, it's polite, and it's all built on a foundation of pure discovery. So, okay, we've got a working driver. Mission accomplished, right? Well, yes, but like we said at the start, this whole thing was always about something bigger. So let's zoom out and look at the really powerful lessons that came out of this journey. This slide really breaks down the key takeaways. First, and this is huge, don't guess, prove it. Real data is king.
The answers are often already documented in the standards if you just know where to look. And maybe most importantly, a lot of devices that seem totally locked down are actually using open protocols. You just have to check.
So here's the crucial point. This whole effort is a massive argument for the right to repair, and it's a direct challenge to planned obsolescence. It proves that the hardware we own often has a way longer life than companies want us to think. The problem isn't the silicon, it's the software. And that brings us to the final thought here. This story isn't just about one audio device, it's a mindset. It's a challenge to look at the tech around you not as some mysterious black box, but as a puzzle just waiting to be solved. So I'll leave you with this question. What device is sitting in your drawer right now, abandoned by its maker, that you could bring back to life?